Today I'm going to be teaching you about law of conservation of electric charge. So what is it? So the total amount of electric charge in a closed system remains constant. Wow, I forgot to put system. So basically, to represent it as an equation, the electric charge, the initial electric charge is equals to the final electric charge, and that's basically it. That's the equation that we're going to use. So now let's do this. Two metal spheres with charges 74 microcoulombs and negative 36 microcoulombs are brought together in contact with each other for a short period of time. After separation, one of the metal spheres has a charge of 25 microcoulombs. What is the electric charge of the other metal sphere? So what we're going to do is just get the initial charges and then set it equals to the final charges, which is going to be Q2 plus the other one is 25 microcoulombs. So now what we're going to do is just basic addition here. So 38 is going to be Q2 plus 25, and then subtract. Moving it to the left side, we will get negative 25 and then cancel this. So Q2 is going to become 13 microcoulombs. So this is the answer. This is the new net charge of the other sphere. So actually, we're not going to use capital Q. We're going to use small letter q for individual electric charge. Okay, there you have it. We're going to use this as a representer. So that capital U is just the sum of the two charges. Okay, now let's start with this. Two identical metal spheres with charges negative 40 microcoulombs and negative 60 microcoulombs are brought together in contact with each other. After separation, what is the electric charge of each metal spheres? So to get this, after separation, we're just going to take the average of the two metal spheres and divide it by each individual. I mean, they have two electric charge, meaning we're going to divide it by 2. So we're just going to take its average. So, and that's going to be the electric charges of each metal spheres after separation. So this is going to be negative 50 microcoulombs. So this is their electric charge right now. Or maybe they just combined, right? They bind it to each other. So the four identical metal spheres are brought in contact with simultaneously. What is the net charge of the four spheres before separation? So to get the net charge, we're just going to add all of them. So don't forget the negative sign though. So Q1 is going to be 60, the other one is going to be negative 21 plus 32 microcoulombs and then plus another 28 microcoulombs. So this is going to be the net charge before the separation. So it's going to be 43 microcoulombs. So after that, how can we solve the net charge of each metal sphere after separation? So earlier I did say that we're just going to take the average of it. But on this thing, what we're going to do is just divide it. So the net charge divide how many metal sphere are there. So 4. We're going to do this. So this is just like taking the average but on a different way. So the net charge of each metal sphere after separation is going to become 10.75 microcoulombs, and that's basically the answer for this problem. And that's it for this video. I hope you learned something, and goodbye.